Module 15. So that's our last module for this semester. We will go over our last chapter, string and arrays. So we only have one more week. We couldn't finish chapter 9. So we will just go over the first two sections from the chapter 9. So actually afterward, the rest of the chapter 9, they kind of just talk about two-dimensional array and the search and sorting algorithm, but I believe you all understand those algorithms. And also the two-dimensional array is, once you're familiar with one-dimensional array, so then you just can add one more dimension, so in the syntax. So I think it's good we just cover the first two sections. So you will see the first two sections in the first half in the chapter 9 will focus on the string operation in assembly language. So Tuesday, we will go over the string primitive instruction we have from the assembly language. So then on Thursday, we will focus on the string procedure from the Irvine 32 library. We will see how they implement that. So then, of course, you will have one string procedure you should implement in your homework assignment. So the first thing that I see what the string primitive instruction we have in assembly language in Mason. So we have 5 primitive instruction we want to introduce in this module. So we'll have the move, compare, scan, store, and the load. So here, why you see so many different instruction, that's just mean you see, for example, move instruction. You have MOVSB, SW, and SD. It just means you will move between byte, word, of double word. So the same thing applies for all the other instruction. But we'll just focus on how to work on that and what those instructions mean. So the first one, let's see what is the move instruction. Of course, we heard about move before, but this move actually we will focus on is we have one destination, we have one source value, so how we can just move. So move SB or SWSD instruction, they will copy the data from the memory location pointed by ESI to the memory location pointed by EDI. So remember we talked about ESI and EDI registers. We focus on to tell you they are source index and destination index. So on the other hand, usually we focus on using these two registers as the reference for the source and the destination. So that's why for your move SB, SW, and SD, we will focus on just by default the memory location pointed by ESI. I will move, actually copy over the value to the EDI. So according to you use the MOVSB or MOVSW, they will copy over 1 byte, 2 byte, or 4 byte. So that's why here we just see, for example, we have a source dword value. So then you have target dword value is not set. So then when you want to use MOVSD, right, because this one is double word. So then you just need to have your ESI and EDI use the offset to have the memory location. So after we call the MOVSD, so then the target value will copy over by the source value. Yeah, so you should know in the move instruction, actually in assembly language actually that means copy. So that's why afterward both target and source, they have the same value. But most of the time when we're using the move SB or SW or SD, we would like to copy over the whole array. For example, this one actually source and target, it just is a 1D word. But actually if we want, we also can do that for the array. So that means here is move SD, actually they are not only just move the value from the SI point to EDI point 2. They also do additional thing is here. So after you have your MOVSB, SW, or MOVSD instruction finished, they also change the ESI and EDI value. The ESI and EDI value will be automatically increment or decrement by 1, 2, or 4. So here you will see why they are 1, 2, and 4, because they are byte word and the D word. So then you will say, how can we decide increment or decrement? Right, so actually the ESI increment or decrement, we will have a new flag we call the direction flag. So this direction flag is DF. Actually, they are control the increment or decrement for the ESI or EDI. So if the DF direction clear, that's mean increment. If you set direction flag equal to 1, that's they will do the decrement. So in order to set or clear DF, you will just do the clear direction flag or ST set direction flag. So what that will affect us if the move instruction, MOVSB, XW, or SD, afterward they will decrement or increment ESI. Right, that means actually we can continue to repeat to work on that, right? So that's why here we will see the other example. Here we will see, right, our source and target, right, they are D words. But now we are not only one value. Let's do 20 dupe. So this one you will see that means we have 20 elements in the source array. So all the value, even the older value is the same, but we have 20 now. So on the other hand, if I want to do is, how about I just want to copy one by one all the 20 elements from source array to target array. Right, I can call MOVSD, right? But additional to call MOVSD, actually I want them to repeat to do that. So we will show you a new instruction we call the REP. So this REP actually kind of the loop, but you don't need to really go to somewhere. The repeat prefix just still check the ECX value. If ECX greater than 0, the ECX decrement and instruction repeat. So on the other hand, followed by the REP instruction, you will prefix, you will have an instruction continue. Before, when we do the loop, they are go to the code label. But REP actually you will have an instruction followed. So then the same thing. What they do is they will check the ECX. So then if ECX not equal to 0, so then we will just repeat. So that's why here your ECX, the same thing, they will do the control of the number of how many times they will repeat. So then here you see we will do 20. So the same thing, we have the ESI is location for the source. EDI is the location for the target. So in order we want to do 20 times. So that's why here we will have our ECX is the length of the source. So then every time, right, so that's why here when we do that, so the first thing we will check if the ECX greater than 0. So then we will decrement, then we will do the instruction. So then we will do that 20 times. So each time when they see the repeat, and also we call the MOVSD, we are not only copy over the value point by the ESI to the EDI, afterward we also decrement or increment ESI EDI by the size. So then here, because we will do the increment, so that's why before that we do the clear direction flag. So then you will see the output like this. So that's originally for the target array. So then that's the source array. So afterward you will see the target will be changed. So that's what we call the dump memory to display the result. So now your turn. If I have an array, it's D word. So I have the value like that. I have 11 elements. So we ask you to do the MOVSD to move all the subsequent array value one position forward toward to the beginning. So that's mean before that. So then you set the last element filled with the 0. So then how you will do that? So pause the video before you see the answer. Then you can check the answer. I hope you pause the video. Now you can see your answer like that. Okay, so continue, we will do the next instruction. So that's similar, but we do the comp. So the comp, you can see that's compare. So again, you have for byte, for word, or D word. So since we will compare two, right? So the same thing. You will see this one, actually, we will compare the memory operand point by the ESI with the memory operand point by EDI. So then you know they compare bytes, words, or D words for different SB, SW, and SD. And again, right, so after they finish, they will automatically increment or decrement for the ESI and EDI. So that's why the same thing, since you want to compare to the array, you will have the repeat prefix. You will follow, actually not follow, it's before you will come SB and SD, SW use. But actually one thing is, remember, you will compare to what? To repeat, right? So sometimes when we want to compare from your ESI with EDI from the array, or some other value, so maybe when you hit something, the condition not right, you will finish and break. So that's why here, besides we have the REP prefix, we also have the REPE and REPNE. So that's me. If that equal, I repeat. But if not equal, I just escape. So that's why if that equal, I continue, right? So that's why they will repeat the comparison. They will increment EDI, ESI automatically until your ECX equal to 0. So then you will find there will be, if they finish, there will be difference. So when we do the REPE, actually we will continue to check if they are equal. If they are not equal, we will break. So that will be the same thing for the NZ. So we just see the example, we just only try one value only. So we have the ESI is the source, the EDI is the target. So you can see their value is different. So we see if not only the different, also we can check they are greater or less than, right? So if the source greater than target, so we jump to L1. Otherwise, we jump to the label L2. So then, right, since here is D word, so we do the comp SD. So afterward, the same thing, they will compare the ESI as the source, EDI is the target. So if that's greater, you jump to L1. So that's we do the JA. Okay, so then you JA to L1. Then otherwise, you see here, since they don't do that, you need to do unconditional jump to L2. Yeah, like we say, the most of the time, those string instruction, they need to compare for the true array. So that's why here we'll see the next example is actually we have an array size, they are both are 10. So then here we want to check if these two array, are they the same? If you see any element they are not the same, then you just break. So that's why here we will have two array called source. Each one they are one array is 10, so target array is anything to 10. So you see we didn't initialize the value. So actually that's the mystery box. We don't know what the memory location there was before. So now anyway, that's practice how to do the repeat, to do the comp SD. So you will have your ECX, you will have your ESI and EDI. So since we will do the moving forward to compare, so we clear the direction flag. So then when we do, we want to continue to see if they are the same, right? So that's why we do the REP repeat. You can do equal or Z. So then when they do that, SD, they